to match pace with the advanced economies, it is very important for any nation to become science and technology sufficient. Keeping this in view, the Council of Scientific and Industrial Research, one of the premier scientific and industrial research organizations in the country, provided blueprints to establish a chain of research laboratories under its umbrella even before independence. Central Road Research Institute, popularly known as CRRI, is one of these research laboratories, the genesis of which was thought of in pre-independence period. The recommendation to establish Central Road Research Institute was accorded by Industrial Research Planning Committee of CSIR in 1945. It was the efforts of Sir Shanti Swarup Bhatnagar, the then director of the Council of Scientific and Industrial Research, and Mr. G.M. McElvey, consulting engineer to the Government of India, Roads, who suggested that the Central Road Research Institute be established in Delhi. Independence provided further impetus to this idea, and Road Research Planning and Advisory Committee of CSIR considered the organizational and building requirement of the Central Road Research Institute, which was by then working in a temporary building. Construction at the site of the present-day building at Mathura Road started way back in February 1951 with about 31 acres of land allotted to the laboratory. The building was inaugurated on the 16th of July 1952 by the then Prime Minister of the country in the presence of scientific and political leadership, including Sir Shanti Swarup Bhatnagar and the founding director of CRRI, Dr. Ernst Zipkes.
CRRI was set up in 1950 with a mandate of conducting fundamental and applied research on hybrid materials. We have earned a reputation of being a solution provider to the field engineers on various problems being faced by them in field. CRRI has taken up several projects of national importance in the past. Institute was the first to demonstrate the bulk utilization of fly ash in road construction. Quality control was also introduced by CRRI in 1962, and our scientists developed a mobile laboratory equipped with all facilities required for testing of material in field.
CSIR CRRI was established with its mandate to carry out the R&D activities in different research areas, which are well supported by infrastructural facilities and have been strengthened with most modern equipment. This division is one of the oldest divisions of CRRI and has completed many complex and challenging projects sponsored by various agencies. Pioneering work was carried out regarding consolidation of marine clay deposits at various port areas of the country, and efficacy of different ground improvement techniques were investigated. Subsoil investigations and design of road embankments in strategically important areas have been done for different road construction agencies. Geotechnical Engineering Division has been in forefront to implement new technological developments like use of geosynthetics, reinforced soil construction, etc. In the recent past, R&D projects on soil nailing for implementing box pushing technique for underpass construction and failure analysis of reinforced approach embankments have received special attention. This division has carried out extensive work on mitigation of landslides and management of hill slopes adjacent to roadway in mountainous areas. Some of the noteworthy contributions of CRRI include landslide and rockfall mitigation measures in Mumbai-Pune Expressway, Zirakpur-Parvanu Road, R&D on subsurface drainage technique, asphalt mulch technique, use of coir or jute netting to prevent shallow landslides. The division has developed expertise on use of waste and marginal materials in roadworks, extensive characterization, mechanical and chemical admixture stabilization of various waste materials like fly ash, copper slag, zinc slag, municipal wastes, jarrafix has been done, and methodologies for utilizing these materials in roadworks have been developed. Recently, this division has prepared database of waste and marginal materials available in selected areas of the country in GIS platform. This division has been acting as specialist consultant and solution developer for road construction industry in the area of geotechnical engineering, especially for subsoil problems, drainage and roadside slope-related issues, waste and marginal materials. In association with Indian Roads Congress and Bureau of Indian Standards, it has contributed significantly towards formulation of several national codes of practice and guidelines. The R&D achievements of Geotechnical Engineering Division have been well recognized through many awards received over the years. The Flexible Pavement Division of the Institute is involved in research in the area of bituminous materials, their testing and evaluation. Research in bituminous pavement design, its failure investigations, design of overlay, recycling of bituminous pavements, warm mixes, etc. are carried out by the division. The division has developed national guidelines for design of flexible pavement overlay using Benkelman beam deflection method. Research has been carried out on use of polymer and rubber modified bitumen, multigrade bitumen, and also developed guidelines for use of appropriate grade of bitumen in different climate regions of the country. Laboratory evaluation and field demonstration have been carried out for use of waste plastic in bituminous roads. R&D activities on use of recycled asphalt pavement and design and performance of microsurfacing for bituminous pavement have also been carried out in the division. The division is also engaged in designing and performance of stone matrix asphalt and use of cold mix technology for bituminous pavements. The division has acquired various testing facilities for flexible pavement. Accelerated Pavement Testing Facility is used to get the long-term performance evaluation of the pavement. Universal Testing Machine is to assess the strength properties of bituminous mixes and ascertain their behavior in the field. The division has facilities to evaluate resilient modulus, fatigue life, and indirect tensile strength of bituminous mixes. Dynamic shear rheometer checks the viscoelastic properties of bitumen at different temperatures. Research work at the division is carried out to use reclaimed materials either in the bituminous layer or in the granular layer for recycling of pavement. CRRI has recently developed a pothole repairing machine which can be transported to the site to repair the pothole instantaneously. The division is also associated with various agencies like NHAI, NRRDA, PWDs and border roads to provide consultancy services also and to provide the technical guidance for their problems. The division has received CSIR Technology Award 2017 on the use of sustainable cold mix technology for bituminous road construction and has contributed to the development of IRC and BIS codes. The Rigid Pavement Division is involved in the activities related to design, construction, evaluation and maintenance of jointed plain concrete pavement (JPCP), continuously reinforced concrete pavement (CRCP), white topping and other forms of rigid pavements, utilization of industrial wastes and byproducts in concrete road construction, instrumentation of rigid pavements, investigation of causes of distresses or failure and taking remedial measures, etc. The division has also contributed to the development of many IRC and BIS codes. Some of its landmark studies consists of study in utilization of high-volume fly ash concrete (HVFAC) for rigid pavement, white topping using high-performance concrete mixes for rehabilitation of exiting asphalt pavement, roller compacted concrete pavement, use of synthetic fibers in concrete, use of industrial byproducts like fly ash, slags, marble slurry dust in concrete mixes, sand stabilization with magnesium oxychloride cement, utilization of copper and zinc slag as fine aggregates in concrete mixes, investigation and remedial measures for distressed concrete pavements, and utilization of recycled concrete aggregate and C&D waste for construction of concrete pavements. The division is equipped with most modern facilities needed for this purpose, such as universal testing machine, compression testing machine, concrete abrasion testing machine, concrete impact testing machine, diamond cutting machine, British pendulum tester, ultrasonic pulse velocity testing apparatus, and lock and capo. The major thrust areas of the Pavement Evaluation Division comprise of pavement performance studies, structural and functional evaluation of highway and airport pavements, rehabilitation design of pavements, pavement deterioration modeling, pavement maintenance management system, road inventory and condition monitoring for road assessment management, investigation of causes of distress or failures and needed remedial measures, and axle load studies for planning of maintenance and repair strategies. CSIR-CRRI has successfully employed state-of-the-art facility, namely Automated Road Survey System (ARSS), for conducting automatic road inventory and pavement condition survey throughout the country. This technology has been successfully used for the first time by CRRI under various research studies. Based on the latest techniques, ARSS utilizes laser technologies, differential global positioning system, DGPS, and video image processing tools, etc., and is capable of collecting field data automatically at traffic flow speed ranging from 30 km per hour to 100 km per hour. The falling weight deflectometer is used to evaluate the structural conditions of pavement. The FWD is designed to impart a load pulse to the pavement surface, which simulates the load produced by a rolling vehicle wheel. FWD data is most often used to calculate stiffness-related parameters of a pavement structure. Fifth Wheel Bump Integrator is indigenously developed by CSIR-CRRI and is used for roughness measurement of pavements. It is towed by a jeep at a constant speed of 32 km per hour. The walking profiler is a precision instrument designed to collect road surface profile data, and the dipstick is used to accurately assess the characteristics and quality of any continuous paved surface. The Institute has facilities for various performance testing on hot bituminous mixes. It uses a high-precision servo-pneumatic valve in conjunction with a low-friction actuator and sophisticated data acquisition, which results in finding out the performance of hot bituminous mixes. In addition, the flexural fatigue test is used to characterize the fatigue life of hot bituminous mixes at intermediate pavement operating temperatures. It provides estimation of fatigue life of a bituminous layer under repeated traffic loading that causes fatigue failures. These failures ultimately result in fatigue cracking, which will cause disintegration of the pavement if not maintained in time. The Institute has also acquired the Asphalt Mixture Performance Tester, Steel Roller Compactor, and Bitumen Mixture Mixer. Distress diagnostics of distressed bridges using non-destructive testing (NDT) has been the core strength of Bridge Engineering and Structures Division at CSIR-CRRI. The division carries out R&D activities related to all aspects of bridge engineering, including construction, distress diagnostics, vibration studies, rehabilitation, management of highways and railways bridges and other civil engineering structures, testing of expansion joints, fatigue studies of bridge components, wind tunnel studies on large spanner bridges and other high-rise structures, load characterization for design and aerodynamic studies. The division has state-of-the-art NDT experimental facilities such as Schmidt's rebound hammer, ultrasonic pulse velocity tester, cover meter, impact echo tester, rapid chloride penetration tester, Galva pulse corrosion measuring equipment, core cutting equipment. The division has experimental facilities for the evaluation of material and structural properties of concrete, steel, and elastomeric materials. The unique testing facilities such as 2000 kilonewton Universal Testing Machine UTM, 5 kilonewton Autograph UTM, ozone testing chamber, humidity testing chamber, Fourier transform infrared FTIR spectrophotometer. Health monitoring of bridges and using advanced instrumentation techniques have been one of the major thrust areas for R&D activities. The division has facilities to experimentally evaluate strains, deflections and vibrations using vibrating wire strain gauges, temperature sensors, load cells, earth pressure sensors, piezoelectric sensors, accelerometers, fast Fourier transform FFT analyzer, static and dynamic data loggers, impedance analyzer, resistivity measuring corrosion sensors, and N3 precision leveling equipment. The division has expertise and facilities for assessment of structural condition of bridges using mobile bridge inspection unit and load testing. It also has facilities for the evaluation of elastomeric bearings and is engaged in the development of comprehensive testing facilities for bridge expansion joints. The division has unique model-type industrial wind tunnel for carrying out wind tunnel investigations for large span and high-rise structures such as cable-stayed bridges, cable suspension bridges, extra-dosed bridges, cooling towers, and chimneys. In addition, the division has the expertise for designing and evaluating various rehabilitation schemes such as plate bonding, external pre-stressing, and epoxy grouting. The technology developed at CRRI has been transferred to industry for social benefits. The Traffic Engineering and Safety Division carries out work in developing traffic management system and strategies for urban road, highways, design of transport infrastructure, assessment of capacity of roadway facilities, ridership estimation for metro systems, imparting knowledge to practicing engineers and traffic police in understanding the traffic management and their applicability for Indian conditions. The division conducts road safety audit (RSA) at different stages of road development and operation, aimed at mitigating the safety problems and reducing the rising road crashes for suggesting appropriate aesthetic and safety improvements to the roads and highways. First ever Indian Highway Capacity Manual, known as Indo-8CM, was developed by CRRI and it was released by the Minister of Road Transport and Highways, Shipping and Water Resources on the 12th of February 2018. The manual is based on extensive countrywide study of the traffic characteristics, covering different types of inter-urban and urban roads separately by including controlled and uncontrolled intersections, coupled with addressing the capacity and level of service for pedestrian facilities. Car driving simulator has been indigenously developed at CRRI to check the driver's good and bad practices with their tolerance capacity to outside challenges and hazards. It provides data on speed of self and fellow drivers and also record drivers' responses while facing any emergency on the road. Car driving simulator also has essential psychomotor tests required for the assessment of driving traits like reaction time, speed and distance judgment, road knowledge test, reactive stress tolerance test, visual acuity and glare test, Vienna test, and hand grip test. These tests have been successfully conducted on drivers of the Special Protection Group as well. Type Approval Certificate and Conformity of Production (COP) for high security registration plates by CRRI has immensely contributed and helped Ministry of Road Transport and Highways in formulation of specifications for HSRP for motor vehicles in India. Ministry has approved CRRI as one of the testing and approving agencies for manufacturers of high security registration plates in India. The photometry lab meets international standards for measuring retro-reflection properties of materials and lamps, that is road sign sheets, road marking, studs and lamps. The division is also engaged in disseminating the new technologies to the PWD engineers and other user agencies and consultants by organizing training programs on road safety and geospatial technologies. The Traffic and Transportation Planning Division aims to promote R&D and consultancy in the area of transport systems planning, GIS and transportation economics. The major objectives are to introduce new innovative approaches for sustainable road infrastructure and evolving policies for sustainable road and transportation systems planning, especially in public transportation and in non-motorized transport. The division has state-of-the-art software facilities for travel demand modeling, microscopic traffic simulation, highway geometric design, image processing, statistical and mathematical modeling, laser-based speed measurement devices, video V-box, bicycle-based road asset management system, and noise and vibration measurement equipment. Significant work has been carried out on urban road traffic and air pollution in major metropolitan cities of India, ridership estimates and economic evaluation of metro rail, especially in Delhi, Ludhiana and Ahmedabad, noise and vibration studies along various metro rails in Delhi, Kolkata, Mumbai, Pune, Hyderabad and other elevated roads and flyovers, geometric design for high-altitude areas, freight demand estimation for iron ore mining areas and development of guidelines for sustainable transportation systems. The division also handles research on environmental pollution due to road traffic. The major activities include detection of environmental pollutants, assessment of pollutant-specific air quality, especially in metropolitan cities, and also vehicle exposure to volatile organic compounds, carbon monoxide, black carbon, including its probable health impact on commuters. The division is also associated with fuel consumption and emission studies in real-world conditions. The institute has state-of-the-art mobile air pollution monitoring van fitted with required sensors to assess environmental pollutants. This monitoring van is extremely useful in the concurrent analysis of both vehicle emissions and ambient air quality, giving both spatial and temporal pollution variation data. The major studies conducted in this area include study of atmospheric aerosols and trace gases for Delhi-Hyderabad corridor, environmental impact assessment studies for Delhi Metro, and traffic and transportation studies and air quality assessment studies and assessment of pollution on Mathura-Agra corridor for Mathura refinery, etc. CRRI is the first institute in the country which undertook studies on real-world on-road vehicle emission measurement for different types of fuel and to measure vehicle emissions in actual driving conditions. The division has facility for testing fuel consumption. This test facility measures records and stores fuel flow data using direct measurement method, vehicle speed, engine RPM, and other in-vehicle parameters for different categories of in-use petrol and diesel vehicles. Using this technology, studies have been carried out related to effect of overloading on vehicles. The division has started working in the area of nanotechnology through a major project on development of surface-enhanced Raman scattering SERS-based sensors for the detection of environmental pollutants. These cost-effective, sensitive and selective paper-based SERS sensors quantify ground-level air pollutants and even monitor toxic substances such as benzene, toluene, carbon monoxide, polyaromatic hydrocarbons and heavy metals. The Information Liaison and Training Division at CSIR-CRRI acts as a nodal point between the Institute and outside agencies for promotion, utilization and implementation of Institute knowledge base. The main activities of the division include dissemination of information, development of human resource, organizing specialized training program for the highway and transportation engineers, and also the marketing of the Institute's knowledge base. Dissemination of R&D results is promoted through a variety of channels like publications, annual reports, newsletters, and participation in technical exhibitions. Training is an important activity of this division, and CSIR-CRRI offers several refresher training and development programs designed to suit the requirement of different target groups. More than 25,000 in-services highway engineers have been trained so far by the Institute. It maintains an active liaison with various highway research organizations, both in India and abroad. The Institute has a well-equipped workshop to provide technical support to all R&D divisions, keeping pace with the modern technology and to keep researchers up to date with the global developments. The Institute has created a high-tech computer center armed with all contemporary capabilities to provide information to the researchers at the Institute. The well-maintained library is equipped to provide all support to the researchers, which houses more than 80,000 books and journals on different subjects. The Project Monitoring and Evaluation (PME) division provides able support for monitoring and assessment of external and in-house projects. Administration, finance, accounts, store and purchase provide ample support to researchers to carry out outstanding research work at the Institute.
There are several milestones fixed for the next 5 years. We are creating national facilities for testing of expansion joints for road bridges, and I am sure that this facility will be extremely useful to the nation as well as to CRRI. Our scientists are working on use of industrial waste in road construction. This is also a major problem in the country where industries are finding difficult to dispose of industrial waste. Our scientists are also working on low-cost indigenous equipments like mobile road safety assessment system, national survey vehicle, drone-based technology for assessment of bridges. The cold mist technology, which was developed for low-volume roads, is being upgraded to high-volume roads. We wish to develop highway safety manual also in the line of Indian Highway Capacity Manual.
Tirelessly engaged in research and development activities, ranging from material behavior to hazard mitigation, from pavement to bridges, from road safety to transportation planning to environmental sciences. Team CSIR-CRRI is marching ahead, keeping pace with the future R&D challenges.